Hi, and welcome to lesson number 3, or, well, as I like to say, my capstone. If you made it this far, then it's quite clear that you have an interest in automating systems. And, well, while I can't display the system because the donkey car isn't up and running right now, I can break this down onto what it does and explain essentially what the modified part for um, the automated object detection based driving project was based on. If you want to know a little bit more about the object detection, I encourage going to the neural network side of this page and watching the video that essentially breaks this down line by line and helps you understand this a lot better. But for automation purposes, we're just going to focus on what this code does and the script and the pseudocode behind it all. Because maybe it might inspire an idea for you to go ahead and either elaborate on this project, which will be available on my GitHub forever publicly, or just do a project of your own. So if you look here, this is where the modifications happen. And this if statement essentially, and of course it's up here as well. However, let's just understand this here. So this if statement is if object info that if this object has any items in here, then go ahead, check if I is less than 1. I is always 0. The reason this is here is so this only runs once. This is a while loop that's supposed to run forever because you're using a stream of a camera feed. Whichever camera feed you choose, this is supposed to run forever until you cancel the program. So if you weren't to put this handler here, then this script and in this loop would run forever. So if there's an object here, check if if I is less than 0. If I is less than 0, then run this script. Then you have the opposite. Well, if objects in it, if the length of the objects in it, this is a list. This is a list with different. This is a multi-dimensional list. If there's nothing in the list, then go ahead. If I is greater than 0, then that means this ran. So go ahead and run this script. All right. That is the most that I can explain it without getting too much into the details. Then the way that we're calling these scripts here is we're importing cell script as s. So s.drive donkey constant, which is what we called it at the time because it's a constant value and drives at a constant speed, and then stop, just the break. And we'll just go to the script here, and here we have stop donkey, and as you can see, driver. This is implicit wait, essentially telling it to wait. This implicit wait is explaining wait until this completely loads because this is running on a Raspberry Pi and it's very slow sometimes, so you want it to wait a little bit. You want it to give it a little bit of a break. Then once this loads, once it's done waiting 10 seconds, it executes the rest of here. This is a class we haven't spoken about, but there's not much to it. It's if there's a select box on the page that you want to go ahead and set a value to something, same process as in lesson 2 for action chain. You just go ahead and call it. You call the select class and pass a path to it. You can even do it from here. You don't have to do it this way. I just did it this way for because it was my first time, but you can just do straight from select value or deselect value and just do it straight from here. But I saved it into a different one and called select value user. Same thing is done here. This is an action chain, a series of action chains actually, where you go ahead and you click on the joystick and then you go ahead and start moving it around. The reason that I move it around a bunch here is because it is a web server running on a Raspberry Pi, and sometimes you have to click it more than once. So this is just assuring that the car is going to stop. Then there's activate a pilot, which if you watch, again, if you go to the neural network side of the house, you'll see how the Donkey Car app works, and it facilitates making neural networks and making pilots for the Donkey Car. Essentially, it makes it very high level to a point where anyone can do. However, it's very time consuming, and definitely read up on that if you decide to go that route. Then this is just drive donkey constant, which is just selecting a max throttle value and then just pushing it. Since if you select the max throttle value, no matter how far you push the joystick, it won't go past the set value there. And this essentially locks it. So no matter what direction the joystick moves, it moves forward. Even if you get these values right, like wrong, we tested it, they're right. We will change this to users in the future, but this just locks it in a forward moving motion. Then we were developing the U-turn. However, this is still in development, and we'll be getting tested on this week at the lab. Another thing to add is if you're planning to make a script which you're planning to go ahead and call into a separate file, do not define main. Just do if underscore name underscore double equal signs main, then put all your functions there and then call it as we showed you here. Import shell script, and there you go. That's all you need. If you wanted to automate any other system, the same, essentially find the system, make a script for it, and essentially write down the logic, import it, and run it. I hope this helped, and thank you for watching.